This is SpaceTime, Series 22, Episode 83. Coming up on SpaceTime, a star thrown out of the galaxy by a black hole, increasing signs of the next solar cycle, and Iran claims it's about to launch another space flight as it accelerates its missile and nuclear programs. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have detected a star that's being flung out of the Milky Way galaxy at a record-breaking speed of over 6 million kilometres per hour by the supermassive black hole at the galactic centre. A report in the monthly notices the Royal Astronomical Society claims the unfortunate star was sent on its course through a gravitational dance with Sagittarius A star more than 5 million years ago. The star, which is now some 29,000 light-years from Earth, is travelling some 10 times faster than most stars in the Milky Way, including the Sun. In fact, it's moving so fast, it'll leave the Milky Way in about 100 million years, never to return. One of the study's authors, Emeritus Professor Gary DaCosta from the Australian National University, says the star's encounter with a black hole occurred at a time when humans were first learning to walk upright. He says in astronomical terms this star will be leaving our galaxy fairly soon and will likely travel through the emptiness of intergalactic space for eternity. The Milky Way's central supermassive black hole, Sagittarius A star, has some 4.3 million times the mass of our Sun. It's located some 26,000 light-years away in the direction of the constellation Sagittarius. The authors discovered this hapless star while using the 3.9-metre Anglo-Australian telescope at the Siding Spring Observatory to search for the shredded remains of small galaxies orbiting the Milky Way as part of the Southern Stellar Stream Spectroscopic Survey. Follow-up observations were then made with the ANU's 2.3-metre telescope, confirming the star's extreme speed. DaCosta and colleagues then traced the star's journey back to its point of origin in the galactic centre. It's thought this star must have originally been in a binary system with a companion star, and this system ventured too close to the black hole Sagittarius A star, which then captured one of the stars into a close orbit while slingshotting the other one out of the system at very high speed. DaCosta says it's great to be able to confirm a 30-year-old prediction that stars really can be flung out of a galaxy by the supermassive black hole at the galactic centre.
I'm part of an international team that is using the Anglo-Australian telescope to get velocities and abundances for stars in stellar streams. These stellar streams are remnants of small galaxies that have been ripped apart as they've fallen into the Milky Way's gravitational potential. And by studying them, we can learn about the distribution of dark matter in our galaxy, for example. But for every field, we don't necessarily have a complete set of targets for the stream stars, so we've used the other spare fivers to look at potentially other stars of interest. And we found this star that has a velocity moving away from us is over 1,000 kilometres per second, and that was a very unexpected and exciting discovery.
That piqued your interest, in other words?
Very much so. Particularly, the star's bright enough that the European Gaia satellite can measure a very accurate proper motion. The motion in the plane of the sky is distinct from the motion away from us. And when we combine that with the observed line of sight velocity, you can trace the orbit back in time, and the orbit, in fact, exactly intersects with the centre of the galaxy. So we're very sure that this star's been flung out of the centre of the galaxy.
And that sort of matches a prediction for a long time now that supermassive black holes, well, black holes generally, I guess, under the right circumstances, won't gobble up a star that ventures too close, but will in fact fling it out.
That's right. There was a paper written first by Jack Hills in 1988, actually before the central black hole in our galaxy was really well established, in which he predicted that if a binary star got too close to the central black hole, one of the stars would be absorbed in towards the black hole and the other one would get a lot of energy and be flung out of the centre of the galaxy and basically escape from the galaxy completely. And that's what we're seeing here. This really is the first time that we've been definitively able to establish that this high-velocity star does in fact have its origin at the centre of the galaxy.
What do you know about this star?
Well, we know that it's relatively young. It's about 2.5 times the mass of our Sun. It's likely to be quite rich in chemical elements because the centre part of our galaxy is where the overall abundance is about a factor of 2 times higher than it is in the local solar neighbourhood. So it's quite metal rich. But with a mass of about 2.5 times and the velocity that it's travelling at, it's going to escape from the galaxy and head off into intergalactic space, which is a very empty place.
What does one call a star in intergalactic space? I know if we have a planet outside our solar system, it's a rogue planet, but what is it, a rogue star? What does one call a star?
Well, I guess you'd call it an intergalactic star. The volume of space outside of galaxies is very, very empty. So, you could have a small population of stars like these that have escaped from galaxies, and they'd be very hard to find.
This is not the first high-speed contender that has been detected that appears to be leaving our galaxy, is it?
No, that's right. We've known for almost a decade, I guess, that there are these high-velocity stars that appear to be escaping from the galaxy, and a fraction of which appear to be coming from the centre of the galaxy. But this is the very first one where we've got precise enough determination of the path of the star to absolutely verify that it's coming from the centre of the galaxy.
Has it been given a catalogue number yet, or a name?
It has the rather prosaic name of S5 because S5 is the stream survey project that we're involved with, and then it's HVS1, high velocity star number 1, I guess with the expectation that we might find more.
Tell me about the survey that you guys have been doing. This is really exciting, isn't it? Looking at the shredded remains of small galaxies orbiting the Milky Way.
That's right. It's actually a very good example of international collaboration. There's a team in the US that uses what's called the Dark Energy Survey camera on the 4-metre telescope in Chile that lets you image large areas of the sky. And they've in fact done quite deep survey of the southern hemisphere sky. And in that imaging survey, they discovered of order a dozen or so of these stellar streams where we believe these are small galaxies that have been disrupted. But you need to take spectroscopy of the stars to get the velocities and the abundances. And the Anglo-Australian telescope with its 2-degree field spectrograph lets you observe up to 400 stars at a time. And that is a unique facility in terms of its field of view and numbers of fibres in the astronomical world. So the US imaging people have collaborated with Australian astronomers here who are experts in fibre spectroscopy to measure these, to observe these streams. And, serendipity can sometimes work in your favour, and we found this particular star.
By studying these stellar streams, this must be telling you a lot about the origins of the Milky Way galaxy itself and how it's grown over
gigayears.
Gigayears, indeed.
Yes, you're exactly right. The standard theory of how the Milky Way has come into existence has had lots of galaxies, small galaxies fall in, get disrupted, and then contribute their stars to the halo and to the disk of the galaxy. In that process, we can try and map out what the distribution of mass in our galaxy is by understanding the orbits of these streams. When a galaxy gets disrupted, some of the stars get energy and move ahead, and some of the stars lose energy and fall behind. That's probably the other way around. And so the whole thing gets strung out as like a string of beads, effectively. And by studying the motions of those streams, we can actually see things like the influence of the Large Magellanic Cloud as it comes by our galaxy. Its extra gravity disturbs the orbits of the streams. And
are we seeing a lot of stuff from Sagittarius Dwarf as well, over on the other side there? That's being gobbled up now as well, isn't it?
Yeah, that's right. I mean, the Sagittarius stream was the first example of this process where dwarf galaxies falling in and being disrupted. I guess it's probably 20 years ago, since it was 25 years ago, since it was discovered. And that is the archetypal example. The core of the galaxy is near the centre of our galaxy, on the other side of the centre of the galaxy, and there's a stream of stars that basically goes across the whole sky. Now, Sagittarius was originally a much more massive system than the small systems that are being disrupted for the streams that we're studying, but it does just show that this process goes on. Sagittarius brought in fact, its own set of globular clusters that are going to be added to the halo of our galaxy once the Sagittarius system is completely disrupted.
With globular clusters, can you tell the difference between a globular cluster and the centre of a shredded galaxy?
That's a very good question. There are a few globular clusters. Most globular clusters have constant abundances of elements like iron and calcium and others. But there are a few globular clusters, like Omega Centauri, which is readily visible in the southern hemisphere sky, where there is a big range in the chemical elements like calcium and iron from star to star. And it's certainly been suggested that those globular clusters where you see a heavy element abundance range may well have been the former nucleus of dwarf galaxies that have been disrupted.
Just so our listeners are aware, normally a globular cluster is a tight ball of thousands, if not millions of stars, which originally all formed together at the same time in the same molecular gas and dust cloud. But when you see globular clusters with stars of very different metallicities, very different compositions, that's the telltale sign you're talking about.
Exactly, yes. And in fact, we have an example in Sagittarius. There's a cluster called M54, which is a very luminous globular cluster, which is right at the center of Sagittarius, and in fact does have a range in heavy elements. So that's almost a smoking gun for this idea.
That's Emeritus Professor Gary DaCosta from the Australian National University. And this is SpaceTime. I'm Stuart Gary. There's more confirmation today that the sun's magnetic poles have flipped, marking the start of solar cycle 25. The new evidence comes from a pair of sunspots with a positive-negative polarity rather than the negative-positive polarity of solar cycle 24. The new sunspots, catalogued as AR2750, first appeared in the sun's southern hemisphere on November the 1st, in the process ending a string of 28 sunspotless days. In fact, the sun's been undergoing one of its most intense solar minima, marked by marathon periods with no sunspot activity at all. The AR2750 event triggered a small B1 class solar flare, which was observed by NASA's Solar Dynamics Observatory spacecraft. Mind you, this is not the first solar cycle 25 sunspot to have been detected. Others were seen on May the 28th, July the 1st, and July the 8th. But these are all interspersed with a similar number of solar cycle 24 sunspots, also identified by their polarity. That's not unusual. This sort of activity, where sunspots exhibit polarities from a mix of different solar cycles, is actually quite normal as the sun moves into a new solar cycle. In fact, the current solar minimum is likely to continue for at least another year before solar cycle 25 begins to dominate. The sun operates through a 22-year solar cycle, which is actually split into two smaller 11-year cycles. During these cycles, solar activity, marked by the number of sunspots seen on the solar disk, moves from a solar minima, where very few sunspots are seen, through to solar maximum, when sunspot activity is extremely high, resulting in increased solar activity with more solar flares and coronal mass ejections, and then gradually falling again to another solar minima. Now, based on this, the sun should reach its next solar maxima sometime around 2024. You're listening to SpaceTime. Still to come, a problem with a parachute has blemished an otherwise successful test for Boeing's new Starliner manned capsule. Iran says it's planning another spaceflight as it accelerates its missile and nuclear programs. And later in the science report, warnings that the measles virus could be causing long-term damage to the human immune system. All that and more still to come on SpaceTime. The European Space Agency's Gaia spacecraft has completed its first 5-year mission and is now well into a 5-year mission extension. Launched back in December 2013, Gaia is revolutionising science's understanding of the Milky Way galaxy. The space telescope's mapping our galaxy in unprecedented detail, measuring the position, movement and distance of some 1.7 billion stars. It's found that stars born in the same stellar nurseries tend to move together through the galaxy for much of their lives. And Gaia's also confirmed that today's Milky Way was formed out of gigantic galactic mergers. Gaia has enough fuel to continue its mission for at least another 5 years. Over the past week, mission scientists and engineers have been meeting in Groningen in the Netherlands to discuss the challenge of processing and visualizing the vast amounts of data which Gaia is producing. This report from ESA TV.
Rotating slowly 1.5 million kilometres from Earth, Gaia is scanning the entire Milky Way. Since 2014, the mission has been mapping the distance, position and movement of 1.7 billion stars to reveal our galaxy as never before.
The scientific impact of the mission already is immense. We see 3-4 papers appearing per day. We're touching virtually every area of astrophysics, from very fundamental predictions of 50 years ago to new things that you see and the dynamics and the history of our own galaxy.
Capturing 70 measurements of every star, Gaia produces vast amounts of data. At a meeting in Groningen in the Netherlands, scientists have been discussing the challenge of processing and visualizing this information.
Gaia is probably one of humanity's greatest missions, one of the greatest catalogs of data that has currently existed for humans to go through. And it's almost impossible to give you all of the ways in which Gaia is impacting astrophysics.
Earthbound observatories provide a snapshot of celestial objects in the night sky. But by measuring how the stars are moving and visualizing that data, astrophysicists are using Gaia to trace the history and evolution of the galaxy. They've discovered, for instance, that stars born together in star-forming factories move in clusters or families throughout most of their lives.
It is mind-blowing. I can't believe we can do this. I could never have dreamed that we could pull away from our position on the Earth and actually see the structure of these kinds of associations. And then you can run time forward and see exactly how they're moving. You can compare and contrast how they're all moving differently. And I think it's a story of vast proportions in our understanding of how stars form and evolve.
Other science teams have used Gaia data to confirm today's Milky Way is formed from giant galactic mergers.
So most of the stars in the Milky Way rotate like the sun in a clockwise sense. So for example, what we discovered last year is a very large group of stars that are going the other way around. And so that's already very suspicious, and it tells you kind of that these stars were formed elsewhere, being such a large group. And it's also very old stars. So that was already the first hint that actually one component of the galaxy is probably made up from stars born somewhere else.
Across Europe, hundreds of people work on the Gaia mission, ensuring the data is accessible to everyone. With more data releases expected in the 2020s, there are likely to be plenty more revelations to come.
Gaia is currently in an extension of the original 5-year mission. We have fuel for another 5 years. What we do is we gather more data, we get better statistics, and then we can derive more precise results.
Gaia is not only mapping the stars, it's giving us a new sense of our place in the universe.
And that report from ESA TV included ESA's Gaia mission manager Fred Jansen, Jackie Faraty from the American Museum of National History, and Mina Helmy from the University of Groningen. And you're listening to SpaceTime. Still to come, Iran announces plans to accelerate its missile development and nuclear programs, masking the effort as another spaceflight. And later in the science report, paleontologists find fossils of a huge clawed predatory dinosaur on Victoria's Otway coast. All that and much more still to come on SpaceTime. A problem with the deployment of one of the parachutes is blemished an otherwise successful test of Boeing's new manned capsule, the ST22E83 Starliner, which will eventually ferry astronauts to and from the International Space Station. The critical launch abort test was designed to simulate a launch or ascent to orbit emergency, during which the capsule and its crew are rocketed away from the launch vehicle, safely landing downrange. The test was conducted at the US Army's historic White Sands Missile Range in New Mexico. The 95-second test flight saw Starliner, mounted on a small test stand, being launched into the sky by 4 rocket engines designed to simulate liftoff and programmed to reach a speed of over 1,000 kilometres per hour in just 5 seconds.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff.
The spacecraft's launch abort engines fired for 5 seconds, and a separate set of orbital maneuvering thrusters intermittently fired for 10 seconds, in order to carry the capsule away from the launch and the hypothetical unstable launch vehicle, as would happen in a real emergency abort situation. The capsule soared to an altitude of around 1,350 metres.
Roll complete. LE cutoff. On track. OMAC cutoff. Picture on.
And then deploying a suite of parachutes at 3 pulses over the course of 25 seconds. The parachutes both slow the capsule down and orient the spacecraft for a safe landing.
40 killed parachutes. Broke parachutes. Mains. SM7.
These included 2 drogue chutes, followed by 3 pilot chutes, and then the 3 main parachutes. Problem is, only 2 of the 3 main parachutes actually deployed.
2 mains fully disreached.
NASA says that 2 out of the 3 parachutes was acceptable for test parameters and crew safety. Meanwhile, Boeing says it's investigating why one of the main parachutes failed to deploy. Still, the spacecraft managed to gently drift back down before deploying its airbags to cushion its touchdown on the desert floor.
Base heat shield jettison. Airbags inflating. CM touchdown.
The pad launch abort test is a major milestone in the development of Starliner, moving Boeing a step closer to its first unmanned test flight of the capsule to the International Space Station, slated for December the 17th. SpaceX carried out a similar unmanned test flight to the orbiting outpost of its Crew Dragon 2 capsule back in March. In fact, SpaceX is now preparing for an in-flight abort test next month. That will test the Crew Dragon 2 capsule by firing its Super Draco thrusters to escape its launch vehicle some 90 seconds into the flight. The Hawthorne, California-based company will also carry out another static test fire of those thrusters next week in preparation for that flight. The last time they did that, it triggered an explosion and fire on the test stand which destroyed the capsule. That problem was eventually traced to a small amount of nitrogen tetroxide which had leaked into the helium line used to pressurize the propellant tanks. The leakage apparently occurred during pre-test processing when the pressurization of the system just before firing damaged the check valve, causing the explosion. Both Dragon and Starliner are essential for NASA's plans to once again launch American astronauts into space from American soil. That's something which hasn't happened since the mothballing of the space shuttle fleet back in 2011. Since then, all American crews have relied on Russian Soyuz rockets to reach space. While Dragon will launch aboard SpaceX's Falcon 9 rocket, Boeing plans to fly the Starliner on its Atlas V, at least until such time as the new Vulcan launch vehicle, which will eventually replace both the Atlas V and Delta IV, achieves its human rating certification in the early 2020s. Both Boeing and SpaceX hope to be flying their first manned missions to the space station early next year. You're listening to SpaceTime. Iran has announced plans to launch 3 satellites into space in the near future as part of a move to accelerate its missile development and nuclear programs. Tehran's announcement comes in the wake of a launch pad explosion earlier this year, which destroyed a Sophia 2 or Simor 3-stage medium-range ballistic missile. The Sophia 2 or Simor is based on old Soviet Union SS-1 Scud missile technology. Put simply, it uses a North Korean Taedong-2 ballistic missile first stage, and a North Korean Nodong-1 ballistic missile, known as the Shahab-3 in Iran, for its upper 2 stages. These are all sourced from Egyptian Scud-B and Chinese Scud-C missile technology. The North Korean Nodong-1 or Iranian Shahab-3 can deliver a 1,200 kilogram warhead or 5 MIRV or independently targeted multiple re-entry vehicle warheads over a range of 2,500 kilometres. As well as using North Korean missile technology, the Islamic Republic is also copying their North Korean allies by claiming their ballistic missile tests are all part of a space program. Of course, North Korea stopped its so-called space program as soon as it perfected its missile technology. Because Iran's missile development program is in breach of UN regulations, Washington's imposed sanctions on 5 people and 5 entities involved in 2 covert networks supplying Iran's missile program. The sanctions have targeted the Iranian Space Agency, Iran's Space Research Center, and Iran's Astronautics Research Institute, which are all fronts for Tehran's ballistic missile development program. In May 2018, the United States pulled out of the Iran nuclear deal, citing multiple violations by Tehran, including continued missile tests, continued sponsorship of terrorist organizations, including Hezbollah, Hamas and Islamic Jihad, and continuing to secretly develop a parallel nuclear weapons program with help from North Korea. Pyongyang has now tested and miniaturized thermonuclear warheads to fit on its missiles. And the International Atomic Energy Agency says the Islamic Republic has explored various fusing, arming and firing systems to make its missiles more capable of reliably delivering a thermonuclear warhead. However, the oil-rich nation insists its nuclear program is for peaceful power generation only. Meanwhile, Iran has been proudly showing off the latest violations of its nuclear treaty by doubling the number of advanced centrifuges it operates and developing new Ion 9 centrifuges which are 50 times faster than those allowed under the 2015 anti-nuclear accord. The announcement came as the Islamic Republic celebrated the 40th anniversary of the 1979 US Embassy raid, which started the 444-day US hostage crisis. As part of those celebrations, the Iranian Atomic Energy Agency switched on a chain of 30 IR-6 centrifuges at Iran's Natanz nuclear facility, doubling the number of working centrifuges to 60, a violation of its nuclear treaty, and allowing Tehran to increase its daily enriched uranium production to 5 kilograms. Under the Islamic State's nuclear deal, Tehran is limited to only using first-generation IR-1 centrifuges. Centrifuges enrich uranium by rapidly spinning uranium hexafluoride gas, separating out the fissile uranium-235 from the non-fissile uranium-238. Iran's enriching its uranium to 4.5% in violation of the Accord limit of 3.67%. The importance of this development is that the introduction of the new centrifuges cuts to under a year the time Tehran needs to have enough weapons-grade uranium to build an atomic bomb. At the same time, Tehran has again prevented UN International Atomic Energy Agency inspectors from entering one of its nuclear facilities. Iran's latest moves follow an increase in the American, British and Australian naval presence in the Gulf. That was triggered by a series of attacks by Iranian Revolutionary Guards on oil tankers in the Straits of Hormuz. Washington's also blamed Tehran for a major attack on a Saudi oil facility earlier this year. The news comes as Iranian-backed Palestinian Hamas terrorists fired another 10 missiles into Israeli villages from the Gaza Strip. The Iranian-financed rockets were launched from schools and hospitals and were tracked by Israel's Iron Dome anti-missile defense system, which successfully intercepted 7 of them. These latest attacks follow a barrage of over 600 rockets launched from Gaza against Israeli towns in May, 2 rocket launches in March, and 1 failed launch from Gaza in September. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that the measles virus could cause long-term damage to the immune system's ability to protect people from other diseases. The findings, reported in the journal Science Immunology, explains why children often catch other infectious diseases after measles and highlights the importance of vaccination against measles. The measles virus causes coughing, rashes and fever and can lead to potentially fatal complications including pneumonia and an inflammation of the brain called encephalitis. In fact, measles leads to more than 100,000 deaths per year worldwide in unvaccinated communities. To reach their conclusions for this study, researchers sequenced antibody genes from 26 children before and between 40 and 50 days after their measles infection. They found that specific immune memory cells which had been built up against other diseases and which were present before the measles virus infection had disappeared from the children's blood after infection. It seems the measles virus resets the immune system to an immature state, leaving it with only a limited repertoire of antibodies to fight illnesses. A veteran who lost his penis in an explosion caused by an improvised explosive device has received a successful donor transplantation, which also included a scrotum and lower abdominal wall. A report in the New England Journal of Medicine claims the ID explosion caused the soldier to lose both legs, along with his genitalia, including penis, testicles, and substantial tissue from his abdomen. The good news is that now, a year on from his transplant, the man says he's able to perform normally. The results are important because up until now, there have only ever been 4 other similar successful transplantations reported. A new study warns that diseases may spread more quickly through marine mammals as climate change-driven sea ice loss opens up new water routes. The findings in the journal Scientific Reports looked at how a virus that caused widespread deaths in North Atlantic harbour seals in 1988 and 2002 later popped up in the North Pacific Ocean in 2004, affecting other species of seals as well as sea lions and otters. They found exposure and infection in the North Pacific peaked after water routes opened up following reduced sea ice, which would previously have created barriers preventing pathogens from crossing the oceans. Paleontologists have uncovered fossils of a huge clawed predatory dinosaur on Victoria's Otway coast. A report in the Journal of Vertebrate Paleontology claims the fossilized theropod bones include a 20-centimetre long hand claw. Many of the theropod bones found at the Eric the Red West site are from a group of theropods called Megaraptoroids. Intriguingly, they look almost identical to those of the Australian megaraptoroid Australovenator wintonensis, which is found in Western Queensland, thousands of kilometres to the north. A new study has confirmed earlier reports showing that there is no increase in loony behaviour or accidents during a full moon. Scientists from New York University carried out the study on the lunar effect after ongoing anecdotal claims of increased admissions to hospital emergency rooms and more crime occurring during full moons. However, a careful examination of police records from various local police departments across the United States found no correlation in police records between crime events and the full moon. Although these kinds of analyses are amusing, a great way to end a radio news bulletin, the findings actually do have some practical implications, especially for the distribution of emergency staff and resources. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary. And you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.